Let's do something where you have to figure out what the angle is. Hey, that sounds great, guys. Since we're trying to figure out what an angle is, what are we going to have to use? It rhymes with inverse functions. Inverse functions. So the cosine of theta in part A is 0.5361, where theta is between 270 and 360 degrees. Well, 270 and 360 degrees is what quadrant? Fourth quadrant. And we shouldn't be surprised because cosine is positive there, and hey, positive number. What we don't know yet is why the calculator is going to give us a bad answer. When we were in acute land and we threw it into the calculator, the answer we got was the actual angle. But since we're no longer acute, we're adorable, the calculator will not give you the correct answer anymore. So, you're welcome. So we have to use the concept of reference angle. So if you would please throw in, oh wait, I think this is set to green. Oh, we got blue. Please do cosine inverse of 0.561. Let's go to 2 decimal places. Yep, 57.58 degrees. However, is 57.58 a number between 270 and 360? Not usually. So what we'll have to do is, let's draw a picture. So this angle right here is 57.58. We don't want that. Instead, we want this one, because that would make it an angle in quadrant 4. Any ideas? So remember, the whole purpose of a reference angle is that the functional values are the same except for their sign, SIGN. So as it turns out, cosine is positive in the first quadrant and also the fourth. So by design, if this angle right here is 57.58, then so is this angle. It's 57.58. So if all the way around is 360, then how do we get this portion where we're not going all the way around, we're stopping at this terminal side here? So if all the way around is 360, take away the 57.58. Good. So 360 minus 57.58, I got 302.42. And if you want, you can check. So now if you did the cosine of 302.42 degrees, you should get approximately 0.361. Now since we rounded that original decimal, it's not probably towards the end there. It may not be 6.1. It could be like 6.2 or 6.0. But being 10,000th off isn't too bad. Good? All right. I would like you to try part B. You'll notice that it's a secant of theta. You'll also notice that your calculator does not have a secant inverse button. Oh my gosh. See what you can do. So if the secant of theta is negative 3.43, that means the cosine of theta would be what? 1 over negative 3.43. You might have to draw a picture. So later on in chapter 7, we learn why the calculator does not give us an answer. Because as it turns out, secant of theta is that value for 2 different angles. for two non-coterminal angles. I don't know the word. Yes, if I put it on Wikipedia, it will be. Everything is true. I edited the mathematician page for famous mathematicians. I put my name. And I printed it out to confirm it. And then I refreshed the page and someone already took it off. So I was a famous mathematician for a minute. It's like Euler, Gauss, and Mike McCraith. Laugh, laugh, giggle. All right, so when you do a cosine inverse of this fraction, what do you get again?
95 degrees.
Well, 106.9 is not in quadrant. Well, what quadrant do we? It's in quadrant 2. So we're given this angle here. I should not draw theta there. I apologize. Instead, we want this angle here. Any ideas?
The reference angle using 106.95, go the other way around.
Yeah, the only thing is not really a reference angle because a reference angle is acute.
Oh.
But you got the same idea. So if that clockwise one, counterclockwise 106.95, then this is also 106.95. Now, do not get accustomed to always subtracting 60. The problem, think of one offhand where you wouldn't, but you may have to only subtract from 180, but I'll have to think. 106.95 FM. What do we get?
3.05 degrees.
Hooray. Check this by doing 1 divided by the cosine of 253.05. That should give you approximately negative 3.43. Again, rounded due to error.